Hello guys, my name is Przemek Chojecki and today we're going to talk about quantum computers because the recent news from Honeywell is that they have the best performing quantum computer out there and there's some data behind it. So let's have a look at that. So for those of you who don't know, Honeywell is a company specializing in high-performance computing, but usually this is outside of quantum. They've been experimenting with quantum for a couple of years now and they might have some results. So let's have a look at that. So basically what they're claiming is that they have a quantum computer with a quantum volume of 64. So you might ask what's the quantum volume, and that's a good question. So usually when there are claims about quantum computers being more powerful than the last existing on the market, you usually tell that in the term of tell that in the terms of how many qubits you have or what are other different statistics. Quantum volume is a notion introduced by IBM researchers, and we'll discuss that in a moment. But there's been some criticism to this notion of quantum volume. Basically, what kind of quantum computer they have is the ion trap quantum computer, and uh, there's some discussion in the blog post that I will link for you down below. There's an explanation of what is quantum computing and what partnerships they have and so on and so on. Still, those kind of quantum computers are in the NISQ era, so noise intermediate quantum systems, which means they are not really useful commercially yet. They might be useful for research. So let's go back to quantum volume and think about why Honeywell is claiming that they have the best performing quantum computer. So there's another text they're linking on how quantum volume is calculated, but we look at the original paper from IBM researchers as well. And they mentioned that into the quantum volume there are a couple of things that are going into. So number of qubits, error rates, and then connectivity of qubits. So basically there is this problem that when you do computation with quantum computers, you have this whole decohesion element and noise coming into your computations, which might make invalid all the computations you're making. And so it's much harder to control quantum computers than it is with classical computers. And so number of qubits not the normal, not enough of the notion to actually go through, because if you were just to compare number of qubits, then D-Wave is winning by large, because I think they have like 8,000 or 16,000 qubits in the latest machine, but they are all connected like in a line. So there's not much you can do compared to more connected kind of arrangements of qubit. Especially the one you would like to have is the kind of a fully connected quantum machine where every qubit is connected with every other, and then you can start talking about quantum entanglement between all the other qubits and get the most out of the computation. So this is like the most nonlinear way of growing your computing power. The problem here is, however, that if you're increasing this way of connectivity, then you're also increasing the noise and you're also increasing the potential error rates between all those qubits connecting, speaking with each other. And that's a huge problem. So that's why you need to also take that into account when you're thinking about commercial applications of quantum computing. So yeah, let's have a look at the original paper. The original paper from IBM, this is called Validating Quantum Computers Using Randomized Model Circuits. The newest version is from 2019, last year, but I think that this dates back to 2017, just as Honeywell mentioned. And there's a nice formula for it. Basically, they start with like the model circuit you want to do computations with, and they look at different implementations in your NISQ device, in your quantum computer you have, so that you can compute the depth of the model. So let's have a look at the formula. The formula basically for quantum volume is here. This is the log of the arc max, mean, m, the m. But basically what it's saying is that it really depends on how you can implement your model circuit, and you go over different circuits to model that. which is basically roughly saying that depending on the number of qubits, depending on the gates, connectivity, and stuff like that, everything is going to this equation. And it computes something. It's definitely a metric worth measuring. I'm not sure this is the best metric to actually compare different quantum computers with, especially that you have different technologies going into different quantum computers. And this kind of criticism is prevalent also in other sources. There's an article from VentureBeat coming from 3 months ago, before Honeywell even, the moment they announced the computer, but before they release it. There's some criticism of Honeywell and the quantum volume. So exactly, like, what is quantum volume really? Is it really useful? And if you go down below, then actually VentureBeat tried to contact a couple of other companies like D-Wave, IonQ, Rigetti, and they said that they don't really care about the notion of the quantum volume. So actually the statement by Honeywell saying that they have the best performing quantum computer means that it's better than IBM quantum computer, because that's the only quantum computer for which quantum volume has been computed so far. And IBM quantum computer had quantum volume of 32. Honeywell quantum computer has the volume of 64. So basically, the whole announcement from Honeywell can be taken down to say that Honeywell is made a computer which is twice as powerful as the computer from IBM. Well, up to this notion of quantum volume. And it's hard to say anything besides that, because it really depends on your approach to quantum computing, on like what kind of technology, methodology you're using to actually build qubits, and then how you actually perform computations. And there are many different metrics that you can measure your computations. So having said that, definitely that's a great progress from Honeywell. It's not clear that they really have the best quantum computer out there, and it's definitely not the case that this is the point where we start to see commercial applications. This is basically also what it seems Rigetti is saying here, that they don't care about quantum volume, they only care about the quantum advantage. And the quantum advantage being this point where you will have problems that are solvable on quantum computers but not on classical computers. And we're still far from this case. Even though there's this claim from, I think that was Google researchers who did, they did solve one problem using quantum computers much better. That was related to basically generating data using some probability, data which was more related to quantum phenomenon. Hence, it was better suited to generate from quantum computer than from the classical computer, using this kind of distributions, probabilistic distributions. So we probably will see some applications of this soon in the future, but for now, quantum computers are still in the research phase. So this is basically what I wanted to say around Honeywell quantum computer right now, but definitely it's worth following the whole space, as there are more and more interesting announcements coming basically every month, every second month right now. Thank you for watching. If you like this content, please subscribe to my channel and see you in the next episode.